Hi, in this video, we will discuss about our third sorting technique, which is insertion search. So in this sorting, we are not performing any swapping of elements. Just we are shifting positions of elements. So in this case also, we are taking the array A of size 5. Okay, so these are the elements we are considering: 9, 3, 7, 5, 2. These are the array elements. So starting from the step 1. So here we are starting from first position in the array. I is equal to 1 we are taking. So first position in the array. So 9 and 3. So first position is 3. So what is the element present before 3 is 9. So at the first position element, the element which is present, we are considering that one as the key element of 1 and 3. This key element we have to compare with its previous position elements. So here that is present at first position, we have to compare that one with its previous position element with 9. So if this particular key value is less than its previous position element, in that case, that previous position element we have to shift to its next position. So that is 9 is coming to first position, because 9 is present at the 0th position. We are shifting that one to the first position. Before 9, no elements are present. Okay, that is the starting of our array is 0th position. At that position, we have 9. So we have to stop our process. So then what is the element position left out? This is 0th position is left out. Place our key value, which is 3, in that position. So there is no need to consider the remaining part of the array, that is as it is. So at the end of step 1, up to first position, okay, we got the elements in the required order 3 and 9. Now that is end of step 1. Step 2. Step 2, we have to consider our I value as 2. So our key element position as 2. So now key element is A of 2 is 7. At second position we have 7. Okay, so that one we are considering. So what we have to do? Same process. That the 7 position is a position of 7 is 2. We have to compare that one with its previous elements. So now 7, what is its immediate previous element is 9. 7, we are comparing with 9. So this key value is less than that particular 9. In that case, what we have to do? We have to shift this 9 to its next position. Okay, so that is 9 is present at first position. That one we are shifting to its next position. Okay, next. Before 9, what is the element is there? 3 is there. So this key element we have to compare with 3. 7 is less than 3. Condition fails. So in that case, there is no need to shift that particular value position. Okay, so 3 is as it is. Before 3, no elements are left out. We have to stop our process here. Now, what is the position left out? First position is left out. No element is present there. So keep our key element in that position. So remaining part of the array is as it is. So at the end of step 2, what we got? Up to second position, the elements are in order 3, 7, 9. Next step 3. Okay, so here I is 3 key position value. So key is equal to a of 3. So what is the value present at a of 3? That is 5. So key value is 5. So that 5 we have to compare with this previous elements. That is 5 is less than 9. Satisfied. If it is satisfied, what we have to do? That 9 we have to shift to its next position. So 9 is coming to this particular position. Next, before 9, what is there? 7 is there. So 5 key element you are comparing with 7. Here 5 is less than 7. That is also true. So what we have to do? That 7 we have to shift one position right side. So 7 comes here. What is the element before present before 7? 3. So 5 is we are comparing with 3. 5 is less than 3, fails. So there is no need to change position of 3. So 3 present at its position, that is 0th position. Before 3, no element is present. So we have to stop our process. Now, what is the element position left out? First position is left out. So keep 5 in that position. So there is no need to think about at the fourth position element. So at the end of step 3, we got the elements in the order up to third position. So next step 4. So I is equal to 4 we are considering. Okay, that is a key is equal to a of 4. So at the fourth position, what is the element is there? 2. Now our key element is 2. So we have to start our comparison with this previous elements. So what is our key value, key position value? 2. 2 is less than 9. Good. What we have to do? That is satisfied. We have to shift 9 one position right. Next, what is the element is there? 7. So 2 is less than 7. Condition satisfied. What we have to do? We have to shift one position right that particular element. What is the element is there before 7? 5. So 2 you compare with 5. 2 is less than 5. This condition also true. We have to shift to 5 one position right. Next, 2 you are comparing with 3 because 3 is present before 5. This is also correct. So shift to 3 one position right. Before 3, no elements are left out. So we have to stop our process. What is the position left out? 0th position is left out. So keep that key value at that position. So like that, at the end of step 4, up to 4th position, all the elements present in the order. We got in the so like that, we can perform this particular insertion sort. So what is the main thing we have to observe is size of array is 5 or n. How many steps you perform? Number of steps are n minus 1. If it is n value is 5, number of steps are 4. In this case, no swapping. Swapping is not present in this insertion sort. Only shifting of elements. So after shifting the elements, if in the empty position, we are placing the key value. So complexity of this particular algorithm is big O of n square. Okay, so here, if you change our comparison strategy, you will get the array in descending order. Now we will take a program for this particular insertion search. Okay, so function declaration, insertion search function you are calling. So here we are reading our data, we are calling the function. After that, we are printing our data. Now see our insertion sort function. Insertion search. Okay, so our array A we are taking int n, which is the size of the array what we have taken. So int I comma j, two variables key. Okay, next. So here loop start, outer loop. So observe, in our case, I value, we are starting from 1, the step 1. So I is equal to 1, I less than n, I plus plus. I less than n, I plus plus. First, what we are doing, we are taking the element which is present at ith position as the key element. From which position? From we are starting our comparisons with its previous elements. So j is equal to I minus 1. How we are performing our comparisons until 0th position. Okay, so that is j is greater than equal to 0. And here, when you are shifting, okay, if our key value is less than a of j value, you are shifting our case. How you are shifting? You are sending element to its right position. That is a of one position element you are shifting to a of 2. A of 2 element you are shifting to a of 3, like that. So what we have taken, a of j value we are assigning to a of j plus 1. So here in our case, we are doing our comparisons up to 0th position. That's why we are decreasing the j value. We're decreasing the j value. Now, after this, okay, so we have to keep our key value in the empty position. So that is a of j plus 1 equal to key. Okay, so after that, we are returning our control to main function. So like that. So for number of steps, 1 we are starting up to n minus 1 position we are taking. That is number of steps. So every time ith position element we are taking key value. Key value we are comparing with its previous elements up to first position element. That is up to 0th position element. So while loop we are taking two conditions. We are combining with the logical end. If both are correct, then only while loop is executed. Now observe the output of this particular one. Array size we are taking 5. 5 elements we have to consider. So like that, we can perform our insertion sort. In the insertion sort, no more swappings, and the complexity of this particular algorithm is a big O of n square.